Hello again, this is Rodolfo Eric Angat, your teacher in Earth and Environmental Science. Today we'll be learning about earthquake locations. This might be able to save your life in the future. Okay, so our essential question for today is how do I predict the locations of volcanoes, earthquakes, and faults based on information contained in variety of maps? Our target competencies for today are the following. I can identify and compare the three types of seismic waves. I can define and compare focus, epicenter, and hypocenter. I can explain why shallow focus earthquakes are more destructive than deep focus earthquakes. I can explain how earthquakes happen. I can explain earthquake maps and point out which areas are likely to experience earthquakes, not predict because we cannot predict earthquakes. Finally, I can suggest ways on how to alleviate the effects of geohazards. Let's begin by defining earthquake. Earthquakes, Earthquake is a sudden and violent shaking of the ground, sometimes causing great destruction as a result of movements within the Earth's crust or volcanic action. Now, this animation here shows us how earthquakes happen. Earthquakes occur when rocks slip along the fault lines, and this line here represents the fault line. Now, we have here the focus, the epicenter, and the earthquake itself. All earthquakes originate from under the ground in an area which we call as the focus. The focus is also what we call as the hypocenter. The place where the two plates collide or slide past each other is what we call the fault line. The epicenter is the earthquake felt on the surface. It is directly above the focus or hypocenter. So this is the hypocenter or focus, and directly above it is the epicenter, and this is where we feel the earthquake. These lines here, these concentric lines, represent the seismic waves which are produced by the earthquake. So again, earthquakes originate from under the ground along the fault lines, and we call that area as the focus or hypocenter, and directly above it is the epicenter. The epicenter is the point on Earth's surface located directly above the focus, so that's the epicenter, while the focus or hypocenter is the location underground where the earthquake begins. And this is where the fault line is. Epicenter of shallow focus earthquake. Oh golly, this one is like so dangerous. When it is closer to the surface, it is felt stronger compared when it happened deep inside Earth. So let's see this animation here. So a shallow focus earthquake would release seismic waves. Of course, these seismic waves will go in different direction, and it will be felt strongly because it's so close to the surface. However, when the earthquake begins deep inside Earth, that is what we call as deep focus earthquake, the seismic waves are released. So when they are felt, they're already so scattered that they are no longer felt that much. So a shallow focus earthquake is more dangerous than a deep focus earthquake because a deep focus earthquake is already spread out, and thus it doesn't have that much strength anymore. I mentioned earlier that earthquakes produce seismic waves. There are three types of seismic waves. We have the P waves, we have the S waves, and we have the surface waves. The first two are what we call as body waves, the P and the S wave. So the P wave is longitudinal, it just moves left and right. Usually, when an earthquake happens, the very first thing that we feel is that we sway, and and the chandelier would be swaying too, left and right. That's the P wave. The S wave, or the secondary wave, moves in a right angle, so it moves left and right and up and down. So it's more dangerous. And then the surface waves, there are two types of surface waves. They are the lob wave and the Rayleigh wave, which we'll be learning as we progress. The surface waves are the most dangerous because they make the ground roll. Among the three types of seismic waves, the P waves are the fastest and the surface waves are the slowest. But though the surface waves are the slowest, they are the most destructive because they make the ground roll. Let's continue on this one. As I've said before, the three types of seismic waves that we identified are classified into two. The body waves include the P and the S waves. The P wave are also known as primary wave, and the S waves are also known as secondary wave. The movement of the P waves is left and right, while the movement of the secondary wave is at right angle. The surface waves are, we also have two examples for the surface waves. We have the Rayleigh and we have the lob waves. Though it is called the lob wave, I don't love it because it causes a lot of destruction and in most cases fatalities. Again, these are seismic waves and they are produced by earthquakes. The body waves include the P and the S. The surface waves include the Rayleigh and the lob waves. And this is how they move. You'll see the differences in their movement. See the red dot, it's just moving left and right, while the S wave is moving at right angle and this one is rolling. This one is the slowest, the surface wave, but it's the most dangerous. P waves are the fastest and they are essentially sound waves. Sound waves are also longitudinal waves. They can travel in solids, they can travel in liquids, and they can also travel in gases. So P waves can travel in solids, liquids, and gases. The S waves, the motion of the S waves is at right angle to the path of the wave. Since the material has to be able to remember its shape, that's the right angle. So the S waves can only travel through solids. S waves cannot travel in fluids. And when I say fluid, I'm referring to liquids and gases. So again, S waves can only travel in solids. Surface waves are the slowest waves. They travel on the surface of Earth and they are the slowest, but they do the most damage. Here's a seismic map of the United States. In what area of the United States can you find the most earthquakes? Is it to the west or is it to the east? I'm sure you've noticed that this one has more red dots. The western side of the United States experience a lot of earthquakes because this part of the United States is along the Pacific Ring of Fire, and added to that we have the San Andreas Fault here. Now, on the eastern side, we are here, North Carolina. We also have a lot of earthquakes, but not as much because we have the Charleston Fault in South Carolina and of course the Madrid Fault. Okay, but within North Carolina, we do not have that much active fault, but of course, earthquakes can still happen. That's why we have these dots here. So Winston-Salem should be somewhere here. And we don't have a lot of earthquakes. Hopefully, it lasts long. So there's it. It's a bigger picture of the area. Now, based on this map here, we'll see that there are a lot of earthquakes here and less earthquakes here. And that is one of the reasons why they put a lot of the nuclear power plants on the eastern coast, because we do not have a lot of earthquakes here and only a few in the western coast or western side of the United States. So again, these are the nuclear reactors of the world. We have them here in the United States, and we have them here because we have less earthquakes in the eastern side. How do they know that Earth has a mantle and core? So we have the crust, we have the mantle, and we have the core. Of course, we have the inner core and the outer core. The inner core is solid. The outer core is liquid. Both the inner core and the outer core are made up of iron. Again, the difference is that this is solid and this is liquid. The reason why the inner core is solid is because of the immense pressure brought upon by the other layers towards it. Now, the liquid outer core, thankfully it is liquid, because this liquid outer core is the one that provides our planet its magnetic field that protect us from the radiation from space. And we've learned that in the first 2 weeks of this quarter. Now, how do they know that we have the mantle, outer core, and inner core? What they use are the seismic waves. Scientists study the seismic waves produced by earthquakes. Remember earlier I mentioned that P waves can travel in solid, liquid, and gas, while the S waves can only travel in solids. You will notice here that the this one here, there the P waves they can travel across Earth, while the S waves they bend because they cannot travel in the outer core, which is liquid. So by analyzing the path of the seismic waves, scientists learned that the outer core is liquid because the S wave or secondary wave cannot penetrate through it, while the primary wave can, because it can penetrate through solid, liquids, and gas. It can travel through those medium. The seismic wave is the one that gave scientists the idea that the outer core is liquid. That is why the secondary wave cannot pass through it. So it bends. And that is how we know the layers of the earth. Now, of course, we don't have earthquakes so often. In some areas they do. But in areas where earthquakes is not often, scientists use explosives because explosives also create waves that can be used to study more about the layers of Earth. So this is the seismic station, another seismic station. So if an earthquake happens here, that earthquake can also be felt on the other side of the Earth, but the only seismic wave that can be felt is the primary wave. So it's only swaying left and right, and that's P wave. Now here, another seismic station. This one detects the deflected S wave. Now you must be asking, where is the surface wave? The surface wave only goes to the surface, so we cannot use it to really learn more about the inside of Earth. The two types of seismic waves that are used by scientists are the P waves and the S waves. Remember, P waves can travel through solid, liquids, and gas, while S waves can only travel through solids. Okay, these are the body waves, and body waves include primary wave and secondary wave. And you can see the deflection of the green seismic wave, which represents the secondary wave. Again, the secondary wave cannot travel through liquid, and since the outer core is liquid, so it is deflected, and that is how scientists learn that the outer core is liquid. Okay. Again, this is the epicenter. It's the one in the middle is the epicenter. Of course, the focus would be here. The closer you are to the epicenter, the stronger is the earthquake. So if the epicenter happened in this region and you are close to it, then you'll feel the highest magnitude. The farther you are from the epicenter, the lower is the magnitude or the lower the strength of the earthquake. So that's a rule of the thumb. The closer you are to the epicenter, the stronger you feel the earthquake. The farther you are, the weaker you feel the earthquake. The magnitude becomes weaker as the distance increases from the epicenter. Of course, that's a focus right there. Okay. Now, earthquake is happening. Ooh, let's see this one.
A powerful earthquake has struck off the northeast coast of Japan and been felt in the capital Tokyo. It's been measured at 8.8 by
Look at
the
the
US
movements
Geological
of
Survey,
the things that are
upgraded from an
hanging.
earlier reading of 7.9, and it's much stronger than a 7.2 quake which hit on Wednesday. There are reports that a giant wave 4 meters high has struck Japan's Pacific coast. A warning's been issued for a possible tsunami of up to 10 meters.
Okay. So when an earthquake happens in the ocean, a tsunami can occur. Tsunami are caused mainly by underwater earthquakes. And usually when the earthquake is a shallow focus earthquake, then it produces a tsunami. How does it happen? Look at this one. So when the earthquakes happen, the waves become bigger, and the closer the waves are to the shore, the higher they become. So this is a shallow focus earthquake, and a shallow focus earthquake usually produces a tsunami or those big waves. An example of those tsunamis like this one. So this again in Japan. So that's a tsunami coming. You might say, oh, that's not dangerous, but the mere pressure that the water brings with it as it flows inland is very, very scary. Look how it affects the land. See that one? See how it washes away the homes easily, the cars and everything else. That is what we call a tsunami. And thank goodness we don't have those things in our area, and hopefully we'll never have this kind of geohazard. So the best thing that you can do when a tsunami alert is given is to go to the highest place. Now don't say go to the top of the roof of your home. If your home is not that strong, this is just what will happen. It will just be washed away by the tsunami itself. See what happens to them? This is really, really very scary, isn't it? So this is what we call a tsunami. Now, surface waves, they are very, very destructive. And it depends also on the type of soil where your house or where the building is erected. In solid bedrock, the surface wave will have minimal damage. But if you have a poorly consolidated sediment or the soil is loose, then there will be a lot of movement and it will break it. Now, if your area is saturated with water, then it would also break it because of liquefaction. Liquefaction is when the foundation of your home turns to mud, and that causes your home or your building or to tilt and even collapse. And we'll be learning more about liquefaction as we proceed. So most of the earthquakes that happen on Earth happen around the Pacific Ring of Fire. You see all the red dots right here. They also happen in the divergent boundary called the mid-ocean ridge. This is the Atlantic, which of course we also call it the seafloor spreading. But most earthquakes mostly happen around the Pacific Ring of Fire. That's a Pacific Ring of Fire. Okay, and there are a lot of volcanoes around the Pacific Ring of Fire, mainly due to the subduction of the more dense oceanic plate in the convergent boundaries. That's North America right there, South America, Eurasia, Africa, Atlantic Ocean. That's the divergent boundary. About 17% of the world's largest earthquakes happen in the mid-ocean ridge. Okay, so earthquakes also happen here, but that's 17% compared to 80 to 90 plus percent happening in the Pacific Ring of Fire. And this is the mid-ocean ridge right here. Remember what I said before about rocks? The youngest rocks are found along the mid-ocean ridge. The farther you are from the mid-ocean ridge, the older the rocks are. This is an example of a divergent boundary, and this divergent boundary is what is causing seafloor spreading in the Atlantic Ocean. That's the mid-ocean ridge. Now, in our area, this North Carolina, so we should be somewhere here. We have the following fault lines, and these fault lines are areas for seismic activities or earthquakes. We have the East Tennessee seismic zone, we have the Central Virginia seismic zone, and we have the Charleston, South Carolina seismic zone. So as you can see, that is we don't have one that is named as North Carolina seismic zone. We are relatively safe from earthquake, but don't be so complacent because Earth is always changing. Circles and squares represent earthquake epicenters, and bigger symbols represent larger magnitude. The effects of an earthquake cover a much larger area than the location of the dot or epicenter. But remember what I said earlier, the farther you are from the epicenter, the weaker is the earthquake. Now, this one is a big earthquake, so it might have affected this area too, but not as strong as when it is closer to the epicenter. So the farther you are from the epicenter, the weaker is the earthquake. And this is the magnitude scale and the modified Mercalli scale. This is how this is how the destructions are expressed, and this is how the strength of the earthquake is expressed, the magnitude scale. Now, if they are reporting in TV and they say the earthquake based on the modified Mercalli scale was 7, then are the things that you need to do. Everyone run outdoors. Poorly built structures, considerably damaged, slight damage elsewhere, and small landslides. So just be guided. But of course, when they give this, when they announce this in TV, they also explain to you what you need to do. But the rule of the thumb is that when an earthquake happens, don't panic and always cover your head or go under the table, a sturdy table, not those folding tables, okay? But if you don't have any other choice, then just use those folding tables. At least they can protect your head. Now, this map shows the epicenter happening here and then the seismic waves traveling outward. Again, the farther you are, the weaker is the earthquake. And this one caused a big tsunami within the area. Earthquakes that happen, I clicked okay, earthquakes that happen in the ocean floor cause a tsunami. And you have to remember this one, when you are along a coast and you felt a slight tremor, or even if you did not feel a tremor, but you observe that the water in the ocean suddenly receded and turned like brownish or grayish in color, that would be the best time for you to run away and go to the highest area, because that might be a sign that a big wave is coming, that an earthquake in the ocean has happened, but you just did not feel it. When the ocean water recedes abnormally, that means a tsunami may be coming. So be knowledgeable about that one. Run as fast as you can and go to the highest area. Okay, let's continue. So that's a tsunami example there, and look at that ship. It was brought on top of the building, and then that one too. Now, someday you'll be traveling, and you'll be traveling in coastal areas. When you go to those coastal areas, especially if those areas are within the Pacific Ring of Fire, please take note of the signs. You need to know where to go in case a tsunami happens. No one really knows when an earthquake happens. No one. No one can predict it. But we do know where they usually happen, but we cannot predict them. So it's always a good idea to know what to do in case it comes. Okay, so we all in those areas that are near the oceans, they have those signs and you need to know them. If they don't have them, ask the people what they do when a tsunami happens because I'm sure they are aware. Now, this is another one. This is called pancaking of building. This is usually caused by seismic wave called the S wave. This is the reason why you should go under the table because it can protect you. Okay, this is one of the reasons. Another reason why you need to go under the table or under the chair. Volcanic eruptions cause earthquakes, but aside from earthquakes, they also cause lahar, and this is the effect of lahar, burying towns and cities, lava that can burn towns and cities, and pyroclastic flow and clouds. Tsunami is another one. Okay, so these are the effects of volcanic eruptions. Now, what should you do when an earthquake happens? May it be caused by a fault line, or may it be caused by a volcanic eruption? The most common thing to do is to drop, cover, and hold on, just like what this young man is doing under the table. So protect your head by going under the table, and when things settle, then immediately leave the building and go to an open area, just like this one too. Okay. I hope I hope this lesson equip you with the knowledge to get a very good grade in our MC assessment. Thank you so much, and we'll see each other again. Bye bye.